This lecture is about transfer learning. In this lecture, we will see that how can we use already trained neural networks which are deep and complex into new scenarios. So we have already studied some of the CNNs like AlexNet and VGG16 and ResidualNet. They are deep and complex networks, and since they are deep and complex, so they have a plenty of parameters. For example, AlexNet, it has 60 million parameters. So to train those 60 million parameters, we need a large amount of data set. So for example, ImageNet, which has a large amount of data, that is used for training AlexNet or VGG16. Now the question is it possible for us to use those deep and complex networks in a new scenario where we have a limited amount of training data? For example, I have a problem of image classification of my own, and my training data set is only 10,000 images. So is it possible to train this AlexNet with the help of those 10,000 training images, training data set? So the answer is given by transfer learning. What are different options if I have my own problem of image classification where I have limited amount of data set? So one of the solution is that I use, since my data is small, so I can use small network. I can train that small network, and then I can apply it for my own image classification problem. But since small network is being used, so it will have its own limitations in terms of performance. Another way is I use somewhat bigger network. For that bigger network, I need to increase the size of training data. So the training data, it can be increased with the help of data augmentation. So that is second solution and second option for my problem, that I use data augmentation to increase the size of my data and then apply it on my image classification task. So in this way, there is a possibility that I get some better accuracy. Now the third option is that I use deep and complex network like AlexNet, which is already trained on a large amount of data set like ImageNet, and then use that pre-trained network on my own problem of image classification. So the transfer learning can help us to do that. Transfer learning can help us to use deep and complex networks, a pre-trained network, in new scenarios and in new conditions. So now what is transfer learning? It transfers knowledge to new conditions. Like a deep network is already trained, and that trained network can be used in new conditions like my own image classification problem. And how it can be used? What is the process of using transfer learning for a new problem? Here is a description for that. Let's say that this is a deep neural network. These are input or hidden layers, and this is you can say an output layer where the softmax is used for classification. This is, you can say, the second last layer, the second last layer and the third last layer. Now in transfer learning, if we have a small amount of data, like I only have 1000 training data available, so what I will do, I will freeze all the weights of these networks, of these layers, and I will change this second last layer and then I will apply my training data on that. So that training data, it will only tune or train weights of this last layer. So my last layer, I have removed and replaced it with my own layer, and the weights of that layer, they are trained by my own training data, which is small in size. So in this way, I can use a pre-trained AlexNet for my own task where I have a small amount of training data available. So another scenario is I have like a moderate size of training data available. So what can be done, instead of removing or replacing last or second last layer, I can remove last two layers and I can replace them with my own layer. It means that so when I apply my moderate amount of data for training, so the weights of these last two layers, they will be tuned, they will be trained, they will be updated, and all of the initial layer weights, they will be frozen, they will not be used, they will not be updated and trained. And if I have a somewhat bigger amount of data, I can replace last few layers with my own layers, and I can use my training data to update the weights of last few layers, and initial layers, some of the initial layers, their weights will be frozen, they will not be trained. So in this way, and at the same time, if my number of classes in my problem, the number of classes are lower or different than the AlexNet problem or ImageNet problem, then I can also change the number of neurons in softmax layer, the output layer. So in this way, we use pre-trained architectures, pre-trained network for our own problem. This is called transfer learning. Now I would like to see why transfer learning works. What is the reason for that? So the idea is that when we have a deep network, a trained deep network, so its lower layers, they have a low level features like this one. You can see here that this low level it's layer 1, it has a low level features like rectangle or square or circle or edges or gradients. So these are the low level features which are in the initial layers, which are learned at the initial layers of a deep network. And as we go deep into our network, then a more higher level features, they are learned at different stages, at different layers. So for example, this is the you can say the second last layer or the last layer of a network that was trained on image classification or image recognition task. So we can see that at a higher level or deep into the network, it has higher level features which are like the faces of different people. But as we go at the beginning of a network, so it will have a low level features. So what we do in transfer learning, that we replace later layers with our own layers, because later layers in a network, they learn high level features, so we remove those layers and replace it with our own layer so that it can learn higher level features according to my own problem, according to my own classification or recognition task. So that is the whole idea of transfer learning, that why this transfer learning works.